Okay, hi. So, as already said, I'm Ingmar Poese. I'm going to talk about how we use ClickHouse in data analytics. And in order to actually understand this, we need to go back a little bit. We come from a very telco-heavy environment. And telco-heavy environments tend to be messy. We just heard about regulations. Telcos have a lot of regulations, but what we're doing, we actually need to take all that data mess and get it sorted out. Now, I was at a meetup here, here in Berlin, but not here at Deutsche Bank in 2017. And we also heard a couple of talks there. And I was one guy in particular whose name, unfortunately, I don't remember, who I got to talking to about that he was using ClickHouse to run iterations of things to learn something. And that got me thinking on, can we actually use this in our own data processing as we go? 2018, we had this developed. So we've been using ClickHouse ever since it came out. I think a month after the first release, we started using it, and it's been serving us really, really well so far. Yeah, this is where we want to go. We want to see how traffic in the network actually goes. So I will not explain this. If you're interested in this, then please come later and see me. I'm happy to talk about this, but not part of this presentation right now. Point is, we have tons of data that is intricate and very colorful, apparently. What we're actually interested in is in our whole software stack that we have. We have all these different protocols down the bottom. You can see them down there, sort of small, this BGP, ISAS, SNMP, DNS, OSPF, NetFlow, NetConf. You name it. Most of you probably have never heard this. Doesn't matter if you have. The point is, all of these come in and they form some sort of, each of them forms a partial view of what's happening in the network. We need to correlate all of this together. And that's actually where the processing comes in. And that's what I'm going to focus on here in this talk, how we actually do the processing. Now, when I talk about data processing, there are unfortunately a few things that we have to keep in mind. First of all, and this is probably the hardest to deal with, is we don't have any control over data sanity. This is mostly stuff that is generated by systems that report on things that is traffic flowing through them, and you see anything. If you make any assumption about what you're going to see, it's most likely going to be wrong. We have, well, to be fair, 99% of the data is sane, but the 1% that is not sane is going to make your life very, very hard. Data is tainted, useless, broken, wrong, and luckily so far has never been malicious, but I can also see how that actually works. As if that isn't enough, we also have no control over when it's actually being delivered. Sometimes it comes straight away. Sometimes there is a hiccup in one of the systems somewhere and it delivers a few minutes late. Other times it stashes things and finds it totally cool to send us a burst of data for 24 hours at 3 in the morning. We have no control over this. Again, the multiple data sources, we have they all have their own timing, their own delivery mechanism. They have their own failure and recovery model. And as I also said before, the analysis that we're doing, each of the protocols that we have actually forms only partial of the picture. So having one source there is nice. Having two sources, you can maybe do something, but you really have to wait until you have everything in place before you can start the processing, whenever that is going to be. And finding that out is a question itself. And as if all of that is not enough, we also have to, or most of the time, we have to install on-prem away from the internet at customers, which again adds a layer of complexity that can be very daunting. What we actually want to achieve in what we're doing, based on that data that I just talked about, is we have a set of processing steps that as soon as data is available from the sources that are needed to actually process this, we have to define a rule that says, okay, so the source data for this is now available. Let's process it and make it available to whoever needs it afterwards. That's what we call a target here at this point. A target is basically managing, in a sense, you can say it's managing one ClickHouse table, and it processes as soon as all of its sources either say I have data or say that data is not going to come. They have to say one of the two. Since we deploy in vastly different environments with vastly different configurations, we need easy adoption of intermediate processing steps, and we also need those intermediate processing steps to be able to look at what's actually happening. With that, we have basically a chain of targets that have intermediate results, correlations, intermediate results, more correlations, and somewhere at the end you get the data that makes that pretty picture I showed before. Furthermore, we are completely stateless, which means the processing that we do has no state of its own. It pulls all of its state from ClickHouse and writes all of its state back to ClickHouse. So it doesn't matter if I start this thing now or in an hour or in 10 hours, it will process everything that it has found, and it will always process everything that is eligible for processing, no matter from when or where that is, which brings me to the last point, easy reprocessing. This is actually something that happened by accident when we wrote this thing. But it comes in very, very handy, since a target will figure out from the ClickHouse database itself when it can process things. If you remove parts of the data, it will just go and reprocess it for you, which makes the whole processing a lot easier. You got a wrong file uploaded by a customer, and they say, oh, sorry, yeah, we corrected it, but you already have processed 6 hours of data using that wrong file. You just delete the stuff from the database and rerun it, and it'll just repair itself. So with that, again, I mean, I think I've made this point quite often, but we deal mostly with failures and wrong information and trying to make sense of it in a way that it is correct. That's what our pipeline looks like. That's 2 different customers that you're seeing here. I'm not going to go into this, just so that you have an idea of what the processing actually looks like. There is tons and tons of targets that all interconnect and get ready and get scheduled, and whenever it's done. The reason I'm showing 2 customers here is the top customer obviously has more processing enabled than the lower one, if you know that the red bubbles is all the stuff that's not turned on. But now imagine not having this once or twice, but having this for 20, 30, 40 customers, all in different configurations, all slightly different processing things. It can get very complicated very, very fast. So that's what I'm actually talking about. And internally we call it Synclick House. It's a working title. There is room for improvement on that one. Nevertheless, what it actually does is fairly simple. Instead of doing the processing directly in ClickHouse, what we do is we basically define a name and a set of prerequisites that can be referenced by others. And each target then defines 2 steps in its processing. The first one is called tokens. And tokens are basically figure out what stuff is ready for processing. This is a normal SQL query that will return just what is ready for processing. And based on those tokens, it can return nothing, then nothing is processed. It can return 1 or 100 different things. Based on those tokens, the second step comes in where we actually have processing. And in that processing, we can now use the tokens and set them into the SQL query, spawning multiple queries at the same time that all work on different parts of the data, possibly in parallel, not in order. And at the end, it'll say, I'm done. And things are processed. The next target that depends on this will then be able to use that. So this also explains, if I can quickly go back here, this also explains how this actually works. Each of these basically has its token query. Once its process queries are done, it hands off to the next one and say, you can run now. The configuration is actually fairly simple. I had this as an animation, but this seems to be the PDF version, so you'll have to stick with me. Basically, what it means is, in the end, you just define two SQL queries that do this, that define the target, and from there, you can easily define what is to be processed when what data is ready. You want to have a table that builds a summary over the past n timestamps if they're available. Let's say you have a table that is supposed to build a summary over the last 24 hours, but this is only supposed to happen when at least 12 of the last 24 hours are available. You write that one in the token query, and in the bottom one in the process query, that's very short down here. This is an insert statement. That's that one. You can write whatever you want in there. You can then actually do the processing. And as long as those 12 hours are not available, it won't process. And if the data for the if the data becomes available in reverse order for some reason, then it'll start processing once those that's possible. Okay. Unintended workarounds. This is just an example that I put in for illustration purposes. What else you can use the token and the processing for? Normally, we use the tokens to be timestamps. So this time range is finished, process it. This time range is finished, process it. We ran into the challenge the other day that we had to apply regexes that are defined by the customer onto a table in ClickHouse. And that's actually not easy to do. If you think of just this table here, you have a couple of timestamps, you have a router, you have an interface, and then some interface description that's completely arbitrary, different for every customer. And I don't want to say volatile, but let's say it suffers sometimes from fat finger syndrome. You want to build rules, regex rules on that one to get to the resulting table where basically the ones that say remove get kicked out, and the ones where you have a result, that's actually added to the result. In order to be able to do that, you need 3 different regexes that you have down here. As far as I can find, and I'm happy to be corrected at this point, there is no way in ClickHouse at the moment to get the group matchings in there. You can find out whether it works. I already see you there springing. You want to go up and correct me, and I'm totally happy about that. Let me finish first, and then you can tell me how to do it. Okay? So as far as I could find, there is no way to actually do this. The way that we work around this is we put the array of regexes into the token query, and we can now spawn 1 query per regex. And that way they become a constant, and that way we can actually run this. And again, I'm happy to know how to make this easier. Just like I said, this is all just examples. If you would like to know more about this, then I'm happy to talk to you. And with that, I am done, and I thank you for your attention. Yeah, in the back. How do you like to ClickHouse? Sorry, I didn't. Can you repeat that? How do you make the clients code to use ClickHouse and some database? Sorry, I should have mentioned that. We run completely software as a service, which means the client never sees the ClickHouse. We run the instance on the premises of the client. The client never sees the ClickHouse. This is all us. I'm not sure. What do you mean by monitor? I'm sorry, I'm not understanding the question. Following tables also token, Yes. Yes. So the pipeline that we have runs continually in the background, right? Which means we schedule this every, I think, 5 minutes. It just reruns every 5 minutes to pick up whatever is there. You can put a target in there that checks if one of the tables is older than n hours from the real time, and make it send you a Slack message or an email if that is ever the case. Targets allow you to do that. You can schedule external commands at any point in the processing stage to alert you if something happens. So we can, for example, we can post to our internal chat program. We can send emails. We can even trigger things based on states that we find inside ClickHouse.
Sorry, maybe a bit below level question, but when it comes to the search queries in some of the topics, that can go wrong.
Mm-hmm.
And if it does midway, how do you then, what is the mechanism you use for that to be actually recoverable without async and so on?
So you mean that there's a half insert into the database? That is a very good question. Luckily, we haven't had that issue. Wait, we might have had that issue at some point. Our normal approach is, so if any insert statement at any point in time ever fails and ClickHouse does not return a success, we break immediately. We ran everything that's running at the moment is can finish. Everything else just breaks and stops. And then normally, if that happens? Normally, you would we would have someone come in and basically remove the tainted data to rerun it. But most of the time, I think ClickHouse is actually clever enough to not make the data available until the insert is finished.
You mentioned ClickHouse scenarios. Similar flows made that file and data. And messages is already inserted in the class. How do you replace the data?
So from the dependency graph, you can see what target depends where, right? Which means all you have to do is you need to find that table where the data was inserted, walk through the dependency graph, and delete everything that timestamp, usually tokens are timestamps, that timestamp touched. And you just go through the database and you delete all of it. The pipeline does it.